Okay, sorry these notes are in two parts. I just ran out of time on my first recording. So example number 3, we need to classify the polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular, and explain our reasoning. So number 1, we need to classify by sides. So number 1, we have 1, 2, 3, 4 sides, so it is a quadrilateral. Quadrilateral. And then we need to tell whether it's equilateral, equiangular, or regular. So remember, equilateral is all sides are congruent. So we see 1 side, 2 sides, 3 sides, 4 sides, all congruent with one another. So it is equilateral at least. Then equiangular is if all angles, so we have 1, 2, 3, 4 angles, 4 right angles, those are all equiangular. So if they're both, we know it's regular. That is a regular polygon. It is a square, actually. So even though it's stretched out on this screen a little bit, it makes it look like a rectangle, our marks show us that it's actually a square. So it's a regular polygon. Okay, then we need to classify number 2 by number of sides. We need to count all of the sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a 12-sided figure. So look back on that other page, a couple pages ago. See, a 12-sided figure is a dodecagon. Dodecagon. Twelve-sided figure, dodecagon. Then we need to see, is it equilateral? Are all of the sides the same length? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides are all congruent. It is equilateral. Then we can check to see if it is equiangular. So we have 1, 2, 3, 4, 5, 6, 7, 8. It is actually not equiangular because we cannot include those exterior angles. We can only look at the interior angles to decide if it's equiangular or not. So it is just equilateral. And it can't be equiangular or regular because it's not convex. For the polygon to be equiangular or regular, it needs to be convex. And it's a concave figure, so it does not work. All right, example number 4. The head of a bolt is shaped like a regular hexagon. The expressions shown represent side lengths of the hexagonal bolt. Find the length of a side. So it tells us, so we have our hexagon here. It tells us it is a regular hexagon. If it's a regular hexagon, I know all of my sides and my angles are congruent. And my angles would be congruent too. But for this, all we need to focus on are the sides. So if we know all the sides are congruent, we need to find the length of a side. So it tells us that 4x plus 3 is going to be equal to 5x minus 1. And then we can solve for x and plug x back into either one of those. So I'll subtract by 4x on both sides. Gives me x. Cancel those. Add 1 to both sides. Gives me 4. So x equals 4. I need to take that, plug it back in. So 5 times 4 minus 1. So we should get each side equals 19 millimeters. Is every one of those sides equal 19 millimeters? And scroll here. All right, example number 5. So the expressions 4x plus 8 degrees and 5x minus 5 degrees represent the measures of 2 of the congruent angles in example 4. Find the measure of an angle. All right, so these are looking back to the hexagonal bolt head. So we knew it was a regular hexagon, so all the angles were congruent also. So this tells us that 4x plus 8 and 5x minus 5 are also congruent with one another. So we can set those equal to each other. 4x plus 8 equals 5x minus 5, and solve for x. And we'll subtract by 4x on both sides. Add 5 to both sides. And we get x equals 13. But we need to find the measure of an angle. So we need to take 13 and plug it back in for x. So I have 4 times 13 plus 8. So work that out. And what do we get? So 4 times 13 is 52, plus 8 is 60. So each angle equals 60 degrees. And that is true of every single regular hexagon. A regular hexagon, the interior angles will always be 60 degrees. All right, that's it for part 2 of the notes. Be working on assignment, the 1.6 assignment.